All right, hi guys. How you guys? How you people doing? How's everyone? Okay. So first of all, let me welcome you guys to the Unacademy JEE English. This is a brand new channel by Unacademy, which you know is India's largest online learning platform for IIT JEE. And on this particular channel, everything related to IIT JEE is being taught to you completely in English. All the concepts, all the pranam to you too. How are you? How are you feeling? All right. So again, as I said, on this channel, especially everything is being taught to you completely in English, so that you guys don't feel left out because of the extensive usage of Hindi in most of the YouTube content. All right. So this is a series which I host for 2020 aspirants, and this is lecture 7 of the topic SHM and waves. And today we'll be talking about standing waves. All right. So that is the topic of discussion for the day. All right. Okay. So just give me 1 minute to get this settled. All right, so welcome to all everyone who's joining us. Okay, so before we get started with today's session, let me introduce myself for those of you guys who don't know me yet. Okay, so my name is Rohit Dixit and I studied mechanical engineering from IIT Delhi, and I've been teaching physics for IIT JEE for almost 8 years now. All right, I myself was JEE rank 447, and I've already coached many students to top ranks in IIT JEE. So this experience before Unacademy was offline. So this is my first online venture, courtesy Unacademy, and you know, in this time of lockdown, hi Russell, you know, neither you guys nor us teachers can conduct any offline classes. So what do you do? How do you maintain your studies? Okay, why messed up, Moisha? All right, so you can also continue your studies on a regular basis, just like you would have in your offline classes by getting the Unacademy subscription. So, what are the benefits of this subscription? This subscription gives you live classes where you get to interact with your educators on a regular basis, just like in an offline setup. All right, so here, trust me, I've taken the sessions. I am also new to the online setup, but I realize that the online sessions are very at par with your offline classes. ये टाइम ऐसा ही है ओके Your Unacademy courses are kept very interactive. They include live polls and leaderboards, so that it's not only all serious studies all the time. It's a lot of fun, and it's a lot of interaction between the student and the teacher. All right. Okay. In your previous year, you teach at which? Okay. Hi Jaswant, how are you? So just which platform? So I was teaching offline, Russell. I was teaching offline at a very famous institute. All right. So again, you also have test series and analysis, which you know in your offline setups you used to have regular testing. So Unacademy is providing you that also on this platform. And of course, the biggest feature is live doubt clearing sessions. So here, all the YouTube sessions that you are attending, they lack a lot of things out of this. So one, I know all the students get so distracted while on YouTube because there are so many, pop-ups and suggestions. YouTube doesn't want you to log off. So once you log on to YouTube, you probably end up wasting a lot of time, browsing, things that you were not planning to see. All right. However, on the Unacademy platform, so all these distractions would be away. So that is the first and foremost best feature that you will have with this platform, with this subscription. You open the app. On that app, everything is about studies only. So you don't waste time on random things on YouTube. Okay, so we are very happy. Thank you for coming on YouTube and Academy English platform. All right, most welcome, Russell. Okay, so just one says, sir, can I know which topic has to be focused on physics? Okay, so in physics, I think every topic is important. There is no topic that you should be leaving out. First of all, you never know with IIT, especially with advanced, they can start asking questions from any topic at any time. So my suggestion would be just make sure every topic is strong for you. In any case, in physics, you should know that most of the topics are interrelated. All right. So when you're solving a problem of rotation, you will have concepts of momentum, concepts of energy, concepts of Newton's laws. Everything would be used there. Similarly, if you look at questions that JEE Advanced asks, so they will ask you a question which will involve two, three concepts. So maybe it'll involve circular motion, it will involve momentum, it will involve energy. So that's the problem with the JEE Advanced and physics, because everything can be intermixed. All the topics can be mixed together to form a question. That is why you cannot leave any part unprepared. All right. Next, of course, along with this subscription, along with all these wonderful features, you are getting access to India's best educators on your Unacademy platforms. So Unacademy is bringing all the India's top educators on a single platform so that all the students have access to quality educators and quality education. All right. So how do you get this wonderful subscription? So it's very easy. First, you need to install the Unacademy app. Once you have done that, you go to the plus section in your app and you select your goal as IIT JEE and you click on that get subscription button. All right, so very easy to get these subscriptions. Once you have done that, you will be moving to the payment page. So these are the plans that you can subscribe to majorly for class 11 students. This is the plan that they should be going for. And 12th and 12th pass, this is the plan that they should be going for. All right. If you're looking for a short-term course also, then you can choose any of these. So when you have any of these plans, here in the box it will say, do you have a code? So there you can write my code, this code RD Live, this is my code. You can use this code and this will give you a 10% waiver on all your subscription fees. All right. After IIT, why you select teaching field? Okay. So first of all, I did not select teaching field. Okay. So you may have heard by a lot of teachers that there are teachers by choice, there are teachers by chance. So turns out I am a teacher by chance. So I started my job in corporates just like most of my batchmates. All right. So I was into business consulting actually. Then I just got bored from there and I switched into finance. So for some time I was into trading. Okay. So I was in finance also. Then somehow I got bored from there also. Yes. So eventually from I for initial like 4 or 5 years of my career, I just kept switching between industries because I wanted to find something which I can do for the next 20, 30 years. All right. And I couldn't get myself to do anything for even 2 years. So I did not stay in one industry for more than 2 years. I would change, I would get bored and change. So while I was switching, somebody suggested, why don't you teach, why don't you try teaching? So that is how I came into teaching. And turns out I really enjoyed teaching. All right. So you will realize, Russell, that after one point in life, only money is not important. Suppose you can earn money doing 10 different things, then you would want to do something that you love. All right. So your job should not only be about earning money, it should also be about, doing something that you love, because this is something that you will do for the next 20, 30 years. All right. So that is how I got into teaching, and I have been teaching for almost 8 years now. So yes, you can figure out that this is some place where I never got bored. It is a very exciting field. I every year I get to interact with the new young minds, and it's fun trying to make them understand the concepts of physics. All right, because I used to love physics as a student. All right. Any change in JEE and NEET syllabus? So I don't know. There has not been any official word. I mean, obviously the yes, 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 yes. Okay, just one. So okay, so I don't know which one are you hearing. There are two lectures that I have taken. One was for 12th pass. Okay, so 12th one, I guess 12th one you must be listening to. So which problems are you trying to solve? Which one are you trying to solve? So as I said, it would have been better if you had attended the sessions live. So that is where your courses, unacademy courses, become important. When you're attending a session live, then you can interact with your educator. When I'm explaining things, if there is something that you're not following, you can interact. And in a course, obviously, once the theory part is over, we will be going over a lot of examples to practice. So there, trust me, with courses, you won't find such a problem. So when you're watching the recorded sessions, that will happen a lot. Okay, yes, yes, yes. Okay, okay, I got it. So that is the problem with the recorded sessions. Okay, because I will only take up everything and I will just talk about most of the concepts once. I mean, only the people if who are attending, if they have a doubt, they may ask me. Otherwise, I'll just go on discussing. And obviously, okay, okay, Moisha, I hope so too. So that is the thing. Jaswant. So that is a problem while watching recorded lectures instead of live ones. If you watch the live lessons, then obviously you won't face such problems. Okay, Jaswant. Anyhow, so all of you who are following us on the JEE English channel can connect with us on the Telegram app using this link. Alright, so why don't we get started with today's lecture? So as I said, this is lecture number 7 of SHM Waves, and today we'll be talking about standing waves. Alright. So what are standing waves? This is what a standing wave looks like. We had talked earlier that standing waves are formed when two waves traveling in opposite direction, and those have to be equal waves. When they superimpose, then they form something like a standing wave. Essentially what a standing wave is that one wave is trying to take energy in this direction, another wave is trying to take energy in this direction. So what happens is that there is no net energy transfer happening in either of the directions. All right, and that is what you call a standing wave. The superposition of these two will result in a wave motion which would be bounded in a region. So all the energy gets trapped in a region. There is no flow of energy beyond this region. All right, so that is what a standing wave is. So let's talk about that. So before understanding the standing waves, we need to talk about the reflection of waves from two ends. So here imagine you have a wave which is going along a string, and eventually it comes across a boundary. So these boundaries are usually of two types. So one is called a rigid end and another is called a free end. So there are two kinds of boundaries that your wave may encounter. Now a rigid end is one which is not free to move. So if the end of the boundary, if the point of the boundary is not free to move, then such an end is called rigid end. So rigid end means this is a rigid end, meaning this point is not free to move, implying this point, the boundary point, is not free to move. Alright, similarly, you could have had another kind of a boundary which you can see here. So here, imagine that there is this string and there is a bead which is in connected to this pole kind of a thing. Alright, so this is also a boundary. There also your string is ending, but this bead is free to slip. So if this bead is free to slip, then this cord is called a free end. So this is what a free end is. Free end means this point is free to move, meaning this point is free to move. So the boundary points, if they are free to move, then such an end or such a boundary is called a free boundary. Or if the boundary points are not free to move, then such a point is called a rigid boundary. Okay, this point is free to move. So what usually happens is that if you send a wave towards this boundary, so from this boundary you will see a reflected wave. This boundary, because this energy, whatever energy is going, it cannot go beyond. Alright, so what happens is that the moment this energy comes here, this energy, entire energy gets reflected and you see a reflected wave. Alright, now I'm not going to show you the derivations of this because this is supposed to be a revision class mostly for 2020 aspirants. So we will just quickly go over this. So when a wave is reflected from a fixed end, the reflected wave is inverted with respect to the original wave, which you can see here. If the incident wave was like this is called the incident wave. Alright, this is called the incident wave. And then the reflected wave would be something like this. This is called the reflected wave. Alright. So if the equation of incident wave was like this, then you will see that the equation of reflected wave from a rigid end would look like this. So the reflected wave always has a phase difference of pi with respect to the incident wave. So the equation of the reflected wave becomes like this. Alright, so I hope you guys remember this. Alright, so moving on. Similarly, when a wave is reflected from a free end, the reflected wave does not see any phase change. Alright, so I'm not showing you the proof of this. Again, that will be done when I'm taking this topic up for class 11. Okay, so however, let's go over the equations. So if the incident wave equation is like this, so what will be the reflected wave equation? It will be like this. Only the direction of the wave has changed. So the minus changes to plus, which signifies that the direction of progression of wave has changed. So waiting for beats and Doppler's effect because this topic is very difficult for me. Yes, and IIT loves asking questions for beats and Doppler's effect. They ask a problem on Doppler's effect almost every year. So those are also very important topics. Definitely. So, but I hope so far you're following this. Let's just take everything in a sequence. All right. So this is what is happening. Now, what happens is, as I said, that standing waves are formed when two equal waves traveling in opposite directions superimpose. So how do you produce two equal waves traveling in opposite directions? So the easiest way practically is to send a wave through a medium and let it get reflected from a boundary. Alright. So you keep sending these waves and you keep getting reflected waves. So these will be two equal waves traveling in opposite directions. So you can see this from these equations also. So here you will see the reflected wave and the incident wave have the same amplitude, same omega, same wavelength. So they are equal waves, but they are traveling in opposite directions. All right. Similarly, even if you see the wave reflected from rigid end, again the incident wave and the reflected wave have the same amplitude, the same omega, and the same wavelength. They are just traveling in opposite directions. All right. So they may have a phase difference, but the omega, the A, the K, they all remain the same, and the direction of propagation is opposite. So this is how you practically achieve this condition, where you practically get two waves traveling in opposite directions which have everything equal. All right. So superposition of equal waves traveling in opposite direction results in standing waves. Any wave propagating in a medium when reflected at the boundary produces another wave of the same kind traveling in the opposite direction. The superimposition of these two waves will give rise to a stationary or a standing wave. So that is what a stationary wave is, as I said. So you in the medium, one wave is trying to take energy here, the other reflected wave is trying to carry energy here, and since they are absolutely equal, what happens is that there is no net energy transfer happening in any of the directions, and that is why this is called a standing wave. So there are vibrations, there are oscillations, the medium particles are vibrating, they have energy, but they are not able to transfer that energy in any direction. All right, so that is what a standing wave is. All right. So as I said, the formation of stationary wave is practically seen only in bounded mediums, because practically that is how you will produce two equal waves traveling in opposite directions. Hi Prashant, how are you? So let's take a look. Let's take a look. So imagine these two are equal waves traveling in opposite directions, and they are given by these two equations. So when you want to find the resultant wave, you know the superposition principle tells me that the resultant motion of every particle would be nothing but resultant of the two SHMs that these waves are trying to give. So whenever a wave is going, so we are talking only about simple harmonic waves. So whenever a simple harmonic wave is passing through a medium, what it does is it gives the medium particles some SHM. Now both these waves will try to give some kind of SHM to particles at different places. So the resultant motion of any particle would be a vector sum of these two SHMs. All right, Prashant. So hope you are following these lectures and you are understanding things. So when these two superimpose, this is the resultant equation that you get. All right, this is the resultant equation that you get, and this is what you see your string to be doing. All right, so your string would be going like this. Then after some time, the string would appear like this. Okay, so let's draw this with some other color. After some time, your string appears like this. All right. So this is what will happen. Okay, maybe I can add a GIF to show you this. And then again, after some time, you will see the entire string becoming like this. And finally, of course, the string would become flat. So this is how you would see your string vibrating as. Now you will notice at this point, what is happening is that these guys would be vibrating like this. These guys would be vibrating like this. These guys would be vibrating like this. So all the parts of the string are vibrating about their mean position, but what you realize is that here every particle is vibrating with a different amplitude. All right. So we will talk about this later also. Again, hi Chrysolite, how are you? So we will study about this again, but this is how the resultant motion would appear. All right. So okay, so here this was supposed to be a GIF. Okay, so let me try and Google that if I can find that GIF online. So let's say, so that you get a good idea about what is actually happening. So yes, these are showing you things. Fine. Okay. Why is this not working? So let me find a good GIF for you guys to watch and visualize this. Just hang on a second. Okay, I think this would be the one. So here, just focus on this. Yeah, just focus on this. This is how a standing wave is. When you have standing wave passing through a medium, this is how those waves would vary. Okay, I hope you can see that and visualize that. So the string is going like this. It's going up and down. It's vibrating like this. Okay, so pay attention to this. This will help you visualize what is happening in a standing wave. So you will notice some things. You will notice some things. One thing that you will notice is that some points are not moving at all right, and some points are moving with a high amplitude and some points are moving with a low amplitude. So what all can you notice from here? What all can you notice from here? You will notice that some points, like in the middle, they are not vibrating at all. These points are called nodes. Some points, the rest of the points are oscillating with different amplitudes. So the point which is oscillating with an amplitude, maximum amplitude, is called an antinode, and other particles have different amplitudes for themselves also. All right. So this is what a standing wave would look like. Okay, I don't know if I could download this. So that is a problem here. Okay, I wish I could download this and add it in my PPT. No, I can't. All right, so I hope you got the visualization in any case. Hi Vineet, how are you? I hope you could visualize what is happening in this. All right, so let's go back to our presentation. So this is what is happening. This is what I was trying to show you here. All right, hi Moses. So this is what I was trying to show you here. That every part of the string will oscillate like this, and every different parts would start doing something like this. So these points, you will notice, are not vibrating ever. They do not move ever from their mean positions. And you will notice that different points are vibrating with different amplitudes. So this point will end up oscillating, doing the SHM with the maximum amount of amplitude. These points with slightly lower amplitudes, these points again with same amplitude, and so on. All right. So yes, as I was saying, so as a result of this superposition, different points at different locations in the medium start oscillating with different amplitudes. So this is where you will find a striking difference from a traveling wave. You remember, in a traveling wave, all the points were performing SHM, but all the points were performing SHM with the same amplitude. On the other hand, in standing waves, though all the particles are performing SHM, so if you take a look at the equation, let's write the equation of SHM. What was the wave equation? Wave equation was 2a sine kx into cos omega t. So if you look at this equation, what is this telling you? This is telling you, if you go to a position x, if you go to some x, so let this be x equals 0. At x equals 0, you will realize what will be the equation at x equals 0. At x equals 0, y would be 0, which means this never changes its position. However, if I move slightly forward, let's say if I reach here, and let this be lambda by 4. So if I move a distance lambda by 4 forward, let's see what the equation of that is. So at y equals x equals lambda over 4, let's see what I'm getting. I'm getting 2a into sine of k is 2 pi over lambda into lambda by 4 cos omega t. Right. So what I am getting is that for this, the equation becomes 2a cos omega t. So you realize this guy is performing SHM. This is the equation of SHM. This guy is performing SHM with an amplitude 2a, with an angular frequency omega. Alright. But as you move to nearby particles, so if you move to the next particle or the previous particle, the amplitude is changing. So here, all the particles are performing SHM with the same frequency. However, their amplitudes are different. Alright, somebody is oscillating with 0 amplitude, somebody is oscillating with 2A, and everybody else is oscillating between amplitudes of 0 and 2A. Now, one more interesting thing, one more interesting contrast. So as I said, these points which are uh, oscillating with an amplitude of 2A are called antinodes. Alright, and the points which are oscillating with 0 amplitude are called nodes. So remember this, we are going to call these nodes. So these are what you will call nodes, and these are what you will call antinodes. Alright, so I hope you can see that. So we will summarize all this once later. Alright, similarly, so I talked about this, the points where the two waves superimpose in phase. So here what is happening is, both the waves, when they are reaching each other, they are completely in phase, so they are producing an SHM of amplitude 2A. So these points were antinodes, and similarly, the nodes are the points where the two waves superimpose completely out of phase. So if they are completely out of phase, they were equal amplitude waves, same frequency waves, so they will completely cancel each other out, and that is why these points will not perform any motion. The motion of the two waves is completely cancelled out. Okay, this is what your node is. Now, the distance between successive nodes or antinodes is half lambda. So I hope you will realize that from the equation. At x equals 0, first time you get 0 amplitude. Next, 0 amplitude, when will you get? When this thing becomes equal to pi. So kx equals pi. What does that give me? So I know k is 2 pi over lambda into x equals pi. So that would give me x equals lambda by 2. So the first zero amplitude that I see is at x equals 0. And the second zero amplitude I will see is x equals lambda by 2. Similarly, third that I'll see would be at x equals lambda, and so on. So after every lambda by 2, you will see nodes. Similarly, the distance between two antinodes is also lambda by 2. Alright, that you can see also from this. Alright, because both the waves had the same lambda, that is why the superimposed wave will also have the same lambda. Alright, so the lambda would be from here to here. So this obviously is half lambda, this obviously is half lambda. Alright, so remember this, the distance between two consecutive nodes and two consecutive antinodes is lambda by 2. And how about the distance between a node and the next antinode? That is lambda by 4. So remember this distance between a node and an antinode would be lambda over 4, where lambda is the wavelength of either of the superimposing wavelengths. This will also be the wavelength of the resulting wave. Alright, I hope everybody is following me so far. Now another interesting thing you will notice is that all the points lying between two successive nodes oscillate in the same phase, but they are out of phase with particles lying in adjacent pair of nodes. Alright, so I hope you remember that GIF that I showed you. So if you notice there, all these particles. Okay, so let's talk about this maybe. So at one point in time, all these particles could be going up. Alright, and all these medium particles could be going down. So you realize all these guys will reach their extremes together. All these guys will reach their mean also together when the string becomes completely flat. So the string is going, it is going to do something like this. It is going to, any part of the string is going to be like this, then become flat and then curve down. So every point within two nodes will reach their lower extremes together, will reach their means together, will reach their upper extremes together. So that tells me all these particles are oscillating perfectly in the same phase. However, the phase of these two adjacent loops, so this is called a loop, by the way. So this, here the particles would oscillate in this loop, here the particles would oscillate in this loop. So all the particles in one loop oscillate in the same phase, but from the very next loop, they have a phase difference of pi. When one is reaching one extreme, the other is reaching the lower extreme. Hello, Namal. How are you? Alright, so remember that. So now let's talk about the standing waves, the equation. Alright, so I already told you, suppose there are two kinds of reflections that you can have, either a rigid boundary reflection or a free boundary reflection. So let's see what the equations I am getting in both the cases. So for standing waves formed by reflection from free end, so if one wave has this equation, the other wave has this equation, alright. So yes, so you will see that the resultant wave has this. So here you will see at x equals 0, your amplitude would be 2a. So let's imagine that this is your x and the x-axis in this direction. So you will see at this point at x equals 0, you will have antinodes here, alright, because of this equation. Similarly, if your standing wave was formed by reflection from a rigid boundary, then the incident wave would be like this, the reflected wave would be like this, and the resultant wave would have this equation, which would tell me that x equals 0 would have a node. So which is this? So here you will realize that if you put this as x equals 0 and your x-axis going like this, then every point on x equals 0 has a node. So remember that. If the reflection is from the free end, then at the end there is an antinode. If the reflection is from a rigid end, then at the end there is a node. Okay. So now why don't we try some problems? Alright, let's try a problem. So in a stationary wave, the phase difference cannot be pi by 3. Is this statement true or false? So tell me quickly. Is that statement true or false? Okay. By the way, none of you are participating in the chat, so I don't even know if all the things that I said, every discussion that I have, if you followed that or not. So please let me know. Please let me know whether you're following everything that I'm discussing or not. If there is some part of it that you're not following, okay, true. Yes, that is true. As I just said, all the particles oscillate in different loops. And in one loop, all the particles have a phase difference of 0. In the other, they have the phase difference of pi by pi. So no two particles in a standing wave can have a phase difference of pi by 3. Only 0 and pi. Yes, one chika. You are absolutely correct. Alright, so let's try another problem. So the displacement of a standing wave on a string is given by, so this is the equation of the standing wave that you got, 0.4 sine 0.5x into cos of 30t, where x and y are in centimeters. You define the frequency, amplitude and the wave speed of the component waves. Alright, which would be the two component waves which were forming this standing wave. And you also have to find the particle velocity of a particle which is located at x equals 2.4 centimeters at t equals 0.8 seconds. So why don't you guys give this a try? So just trying in the chat to let me know that you guys are trying this. And I hope everybody followed all the discussion that I had so far. I hope it jogged your memory and you followed it. Alright. So yes, that is correct. The amplitude of the constituent waves would be 0.2. Very nice. So what happened to Moesha and Vineet? Okay, AP is trying. How about Moesha and Vineet? Did Moesha get disconnected? I think so. Okay, so frequency you are saying is? Okay. Okay, yes, that is correct. That is correct. Alright. So you should know that if you have the equation for your standing wave, you would be able to draw information for the constituent waves also. Okay. So yes. Right. Alright. Yes, Vineet. Yes, correct. Alright. And wave velocity, obviously, yes, that is also correct. Alright, so you guys are getting a hang of this, which is good, which is good. Okay. So I hope everybody is able to solve this. This is very easy. Okay, so this is of the form of this. So this has a form of, you should know, if individual waves were a sine kx minus omega t, and the other wave was minus a sine of kx plus omega t, then this is the form that I would get. Then resultant wave takes a form of 2k sine kx, alright, times cos omega t. Alright, so I know it in this form, so these must be my two individual waves which are. So middle class boys अपने ड्रीम कैसे अचीव करें? Okay, पढ़ाई करके, मेहनत करके. I don't know any other way. All right. Okay. So I don't know. I mean, I only knew about that. These days, a lot of people are achieving their dreams very in very different ways. I don't know. That's the only way I know. All right. And depends on what kind of dreams do you have. All right. So anyhow, so if I knew this, then I could find the individual amplitude. So obviously the answers would be A would be zero point 0.4 over 2, which is 0.2. How about K? So K, obviously K would be 2 pi over lambda, and that would be 0.5. So from here I could have found my lambda. Lambda would be 4 pi. Alright, similarly omega. Omega I know was 30. So my frequency, omega was 30, and I know frequency would be omega over 2 pi. So that would be 15 over pi. So once I know the lambda and I know the frequency, C is also easy to calculate. C is nu times lambda. So if I multiply these two, I am getting 60 centimeter per second. Alright. So I've got all the answers. Now what about the particle velocity at this? So that is very easy. That is very easy. Oh yes, I just realized there is some bit of lag. Is it 10:30? No. Okay, so my net has started lagging before 10:30 only nowadays. Okay, let me see what I can do about this. My net has made this a habit. Okay. So, dear Lord Friendzone, do you want to get blocked or something? Please don't say anything frivolous in my class. All right, there are students who are trying to study, and this stream is for 2020 aspirants who don't have much time to waste in any case. All right, so please, if you are looking for some time pass, please you can go elsewhere. There are a lot of options on YouTube. All right, you don't have to come here and disturb others. Okay. नेट कौन सा है 50 Mbps broadband anyhow. Okay, I hope it is smoother now. The net seems to have stabilized now. All right. Okay, so how about the particle velocity at x equals 2.4 then? So let's try and find out the SHM equation for that particle. So for or at still lag. Seriously. Okay, which is weird. My net seems stable. There shouldn't be too much lag now. It's good. All right. So let's try and find out the SHM equation for particle at x equals. So at x equals 2.4. Let's see what is the equation that I'm getting. I'm getting the equation for that particle's motion as 0.4 times sine of 1.2 cos of 30t. Alright, so this is the SHM equation that I have for that particle. The particle that is at x equals 2.4. Alright. Next, if I wanted to find the particle velocity, all I need to do is find dy by dt. And dy by dt you will realize will be zero point 0.4 into 30 into sine of 1.2 into cos of 30t, sine of 30t. So all I need to do is how to find sine 1.2. Okay, yes, even I was wondering about that. Maybe you can roughly approximate it to, I don't know, pi by 3. Maybe about around pi by 3. So that is what you can do. You can roughly take this as pi by 3. Alright. And that's the best that I can tell you. Alright. You can assume 1.2 roughly as pi by 3. And take an approximate answer. The answer would give you a range at least. Otherwise, in the question, they would tell you the value of sine 1.2. Okay. Yeah, so that is what. You can find the value of sine 60 and use that approximately. Alright, now you just substitute the value of t here and you will be good to go. So okay, this is also coming. This is coming 2.4. This is coming 2.4. So 1.2, 2.4. Okay. There must be something similar about them. That is why they gave you such values. Okay. I don't know. I don't remember any such values, but maybe there is something to these values. Okay, so that is how you will finally find the answer. Alright, so whichever particles velocity or acceleration you need to find, just put the value of x, find the SHM equation for that particle, and then you can derive the expression for velocity or acceleration of that particle. Okay, so I hope that is clear to all. Alright, if that is clear to all, then I will move forward. Okay, so let's move on to the next question. Let's get some more practice. Alright, so what does this say? This says the vibrations of a string of length 60 cm fixed at both ends are given as this. Alright, where x and y are in centimeters and t is in seconds. Alright, now it says what is the maximum displacement of a point which is at x equals 5 centimeters. So you have to find that. Alright, then what is the velocity of the particle at x equals 7.5 centimeter at t equals 0.25 seconds. Next, you have to find where are the nodes located along the string. And finally, write down the equations of the component waves whose superposition will give the above wave. Alright, so let's see you guys write these answers for these. Let's see if you can give me the answers of these. Alright. Okay, so I hope you guys are trying. I think Mohisha got disconnected. Otherwise, Mohisha would be trying too. But Vineet and Vanshika, you guys can keep on trying and answering. All right. So amplitude is 2 root 3. Yes, of course. You substitute the value of x, you get pi by 3. Sine of pi by 3 is root 3 by 2. So absolutely, the first answer is correct. So you got that right. So this is right. How about the other parts? Let's see. Alright. So all you need to do is just start substituting values in this equation. And that is it. The questions will not be very tough. See, the idea of standing wave is tough. The questions, trust me, are easy. Understanding the idea might be tough. How they are getting formed, what exactly is happening, that might be tough. But once you move to the question solving bit, you will realize that the question solving is way easier. Alright, all you have to do is just substitute values in that equation. Okay. Alright. So let's see some more answers from others also. I hope, Vineet, you are also trying. Okay. So once you have done that, let me just write a few conclusions. Okay, so 12 meter per second. All right. So let's see if that is correct. So I have my equation as y equals 4 sine kx. Okay, k is pi by 15 cos of 96 pi t. So now let's start getting the answers. So in the first part, I've been asked what is the maximum amplitude at the position of x equals 5, right? So for part 1, for x equals 5 centimeter, my equation becomes y equals 4 sine of pi by 3 cos of 96 pi t. So obviously this is a equation for SHM which has an amplitude this. So amplitude for this would be 4 sine 60, which is 2 root 3 centimeters. Right, so just remember the units. The unit would be centimeter. All right. So okay, so Vanshika has given me all the answers. So let's see. Similarly, you have to find next the velocity of point at x equals 7.5 at t equals this. Okay, so for part 2, what I've been told is find v if x equals 7.5 and t equals 0.25. So what I need to do is first I need to find the SHM equation for the particle which is located at 7.5. So let's see what is the location of that. So I will get y equals 4 pi 4 times 4 times sine of, this will become pi by 2, all right, into cos of 96 pi t. So all I need to do to find the velocity is to differentiate this. All right. So let's differentiate this. So let's see what my dy by dt is. Dy by dt will become, so 4 into 96 pi into sine of 96 pi by t. Okay, so this is coming with a minus sign, but minus sign will only give me the direction in which the particle is going. So to find the value, all I need to do is substitute the value of t. So obviously at t equals 0.25, let's see what I am getting the answer as. So dy by dt would be this. Okay, so this I will need to calculate with my calculator. All right. So minus, let's see, minus 4 into 96, so 384 pi into sine of, you will have 96 over 4, which is 24 pi. So sine of 24 pi obviously will be 1. All right. Okay, so what are you saying? Okay, these are the constituent wave equations. Okay. All right. Yes. They seem absolutely correct. Absolutely. Okay. So obviously this becomes 384 times pi. Let's see what the value of that is. 384 times pi, and the units here are in centimeter per second, by the way. So just remember about your units. So obviously this is coming out as this centimeter per second. So obviously in meter per second it will be around 12 meter per second. So yes, Vanchika was absolutely correct about this. All right. And the nodes are located at, for location of node, all you need to do is find the positions where the amplitude is 0. Where the amplitude is 0, matlab x pi over 15 should be equal to n pi. So whenever this term is equal to n pi, you know that sign becomes 0. So that is it. So you will realize that x would be n times 15. Alright. So obviously the nodes would be at x equals 0, x equals 15, x equals 30, x equals 45 and x equals 60 because this was a 60 centimeter long string. Alright. So those will be the positions of the nodes. So answer for the third part obviously is, so let's write this third part, x equals 0, 15, 30, 45 and 60. So you will have 1, 2, 3, 4, 5 nodes in this. Alright. Okay. Next part is super easy. Next part is writing down the equations of the component waves. So you know this is 2a. So the amplitude of each would be a. This you know is k. This you know is omega. So writing down the individual equations is very easy. And since these are equations where sine 0 is 0, so obviously y1 would be 2 sine kx minus omega t. So k would become 15. Okay. So just write this sine of pi x by 15 minus omega t 96 pi t. That would be the equation of the first wave which is superimposing, and the second wave would have an equation of minus 2 sine of pi by 15x plus 96 pi t. So this would be the equation of the constituent waves. Okay. Sine 24 pi is 0. Oh yes, oh yes, oh yes. Oh yes, what am I saying? Yeah, you are absolutely right. Okay, that is why they gave such huge calculations. Absolutely. Absolutely. So the velocity would be 0. Yes. Yes. I saw your answer and I just wrote that. I also did not pay attention. Of course, sine 24 pi is 0. Alright, that is why they had given you such a long calculation. Because you never needed to do it. Alright. So those are all the answers. I hope everybody agrees with these and everybody followed this. So what happened to Vineet? Vineet, are you still here? Did you follow all the answers? Okay. So first of all, I wanted to do this. I wanted to write comparisons between traveling waves and standing waves. So because I have a sheet blank here, so let me write it here only. All right. So let's write about comparison between standing and traveling waves. So comparison between standing waves and traveling waves. So what are the striking differences that you see? So in terms of in standing waves, so here let's write traveling waves, and on the other hand side we will discuss what we have seen in standing waves. So okay, so let's divide this into two portions. So standing waves here and traveling waves here. So the first thing you will notice is that the amplitude of all the medium points in a traveling waves was equal. All right. So that is the first comparison that you can draw. So one was all points, all medium particles oscillate with the same amplitude. I hope you remember that from our discussion yesterday. Okay, Moisha, I figured you got disconnected. All medium particles oscillate with same A. And here, obviously, all medium particles are moving with different A's, but they are fixed. So here, comparison would be all particles, all medium particles move with different A's. Alright, next thing you will notice is भाई MBA कर लिया. Okay, what is this? Arnav says, sir, I'm confused which Unacademy JEE channel to follow, yours or Namo's, please help. So whichever you understand better. Arnav, whichever you understand better, wherever you feel more comfortable. That's it. And Bharat Sehgal says, bhai MBA kar liya. Okay. I don't know who are you talking about. Bharat Sehgal. Alright. Next you will realize that all medium particles here, all adjacent particles or adjacent medium particles were always moving in different phases. So adjacent medium particles oscillate with different phases. So I hope you remember that from our discussion yesterday. Oscillate with in different phases. And here you will realize that all adjacent particles which were in one loop, they were always oscillating in the same phase. Okay. Moisha, no comments like those. Please. This is a public platform. Please be respectful. Okay, no comments like that. Alright. Here obviously adjacent medium particles oscillate in different phases. In the same phase. So every point in one loop was oscillating in the same phase. Okay. MBA कर लिया. Who are you asking, Bharat? Who are you asking? Okay, if you're asking me, I haven't done any MBA, by the way. So next, if you want to study, then only stay in the chat. Otherwise, there are students who are trying to study. Please, if you are just looking for some time pass, if you're just here to make random remarks in the chat, then I will have to get you blocked. So please, in my session, try to focus on studying and let others also study. Okay, Bharat Sehgal. Anyhow, so here there was energy transfer happening. In this case, energy gets transferred. Energy transfer is happening in one particular direction. So energy is propagating in a direction. So that can be either right or left, whatever the direction, but there is energy propagation. Energy propagation continuously. Alright, energy is propagating continuously. And here there is no net propagation of energy. No net propagation of energy. Alright. Hi, 0 Kelvin. Okay, so I am not really sure, but they have a criteria. If your annual income of your family is less than some amount, then you fall into that EWS category. Okay. Next, both these equations, you will realize equations which are representing traveling waves and equations which are representing standing waves. Both of them satisfy this differential equation. By the way, this differential equation, you will realize, you can check it, is followed by both. Both the equations will satisfy this. So you realize we had earlier said that fx plus f of ax plus minus bt is only one family of solutions of this differential equation. The other family is this. The other family is this. So one family was f of ax plus minus bt. This will follow this. Another was any a sine kx into cos of omega t. This kind of equation will also be uh, satisfying this differential equation. So this is what your traveling wave equations are. This is what your standing wave equations are. All right. So Friday class में 15 मिनट लेट था. Okay. What the hell? Okay. So I guess I will have to get you blocked. So Moisha says, no disrespect and no offense to anyone. Okay, so this is not a platform where you will discuss such opinions. Moisha, if you want to have a discussion with somebody, alright, then you can have them at a different platform. This is a platform where you should be focusing on your studies, alright? So not on all these kind of discussions, alright? Okay. See, everybody has to do their jobs, guys. You won't understand. You are still kids, you are still students. When you grow up, you will realize that everybody has a job, has a role, so they have to do some things. Alright, that does not mean anything. Okay, enough. Alright. Thank you. Alright, so now let's talk about standing waves on a string. So when we talk about standing waves on a string, so when you're vibrating a string which is fixed at both the ends, so this is the first possible mode in which the string can vibrate. This is the second possible mode in which the string can vibrate. This is the third possible mode. So there are multiple modes of vibrations of a string. So if you just pluck a string, stretch a string and leave it. Thank you. Okay. So that is what. So a string can vibrate in multiple modes. Okay. So these are different possible modes of vibrations of a stretched string. Okay. So either it can vibrate making one single loop, or it can vibrate making two loops, or it can vibrate making three loops, and so on. All right. So if I am trying to notice, if suppose it is vibrating in this first mode, the first mode of vibration. All right. If suppose if it is vibrating with n loops. Okay. So let a string be vibrating forming n loops. All right, so just give me a second. Hello. Yeah, there is some bad signal in this panel. Yeah, I don't know what probably like. All right. Okay. In evening, why it was freezing? Okay, I don't know what was happening. I had to restart my laptop. In the evening. All right. So initially there was some problem. I don't know. No. The class is not over. You wish. So let a string be vibrating, forming n loops. Now what I can say about this? Okay. Now what I can say about this? So I know distance between or length of any loop length of any loop would be lambda by 2. So if the total strength, if total string length equals L, then I know if it has n loops. Okay, okay, Bharat Sehgal. I think I've warned you enough, and I will have to get you blocked. Just wait. You should do rather in board than this. Yeah, but it is easier to draw images here. All right, trust me, my drawing is very bad. Okay. So if the total string length is L, then lambda by 2 into n would be equal to L, right? Because if there are n loops and each loop has a length of lambda by 2, okay, try and bear with this. Okay, so the advantage for this, yeah, see, the advantage of this is that everything that I'm writing here will get saved in the PDF, and when I upload that PDF for you guys to download, all my handwritten things will also be there. All right. If I'm teaching on a board, then I can't do that as well. And here I am providing these PDFs also for you to download, which you can study from later. Okay. So here I will get lambda would be equal to 2L over n. All right. And I know the C, the speed of the wave in the string would be fixed if I fix the tension. All right. If tension and mu are fixed, then obviously C is fixed. C being the wave speed. All right. Yes, I know. Trust me, I am also more comfortable with board. I've been teaching for past 8 years on boards, but what to do? This seems to be working fine for online. All right. You get PDF notes. That's a huge advantage. Okay, what is not understandable? Okay, what is not understandable? Oh, you're talking about smart board. Okay, yes, I joined this in the lockdown period. So, and I don't know if at all I will get access to a smart board, and if that ever happens, when will that be? Right now, it is not possible. Right now, it is not possible for me to get access to smart boards. So, this is the best that I can do. Okay. So, C is fixed. So, therefore, what are the possible frequencies? Or what will be the frequency? The frequency would be C over lambda, and hence that would be NC over 2L. So if any string is vibrating in n loops, then this is the frequency of vibration that it will have. Now this is called the natural frequency. All right, why natural frequency? If the medium is naturally disturbed, then these are the frequencies in which it will vibrate. So okay, in SHM I did not talk about force oscillations. So if something is naturally disturbed and left, then it vibrates with the frequency which is called its natural frequency. I can make it move with some different frequency also. This is forced oscillation. All right. So this does not happen with natural frequency. This will happen with any frequency that I want. Okay. So simple whiteboard. Okay, but we have been told to teach like this. So I don't know. Okay. Let's see. I will see. Okay, what's my age? A lot. It's a huge number. I am very old. Okay. So now what you will realize is that what is the minimum possible frequency of oscillations? So new min would be if I put my n as 1. So that will be C over 2L. What will be the next new? So this we call nu naught. We give this a special name, nu naught, and this is called the fundamental frequency. Alright, this is the smallest possible frequency that you can have the string vibrating in. Alright, we didn't talk of truncated SHM2. Yes, okay, yes, you are right. I thought we had discussed so many problems, I did not want to give you guys an overdose of SHM. That is why I skipped that part. So this is called fundamental frequency. Fundamental frequency. This is also called the first mode of vibration. First mode of vibration. Alright, now this is also called the first harmonic. So these are the names that we use for this. Alright, when the string is vibrating in this mode, when the string is vibrating in this mode, where it is vibrating with the minimum possible frequency, you call that the fundamental frequency, you call this mode of vibration as first mode of vibration, and you call this the first harmonic. Now the next possibility is, let's call this new one would be 2 times this. So now this is called the second harmonic, or the second mode of vibration. Second mode of vibration, because that is the second possibility that I can have. Alright, this is also called the second harmonic, and this is also called the first overtone. Alright, so you guys need to remember these terms. Okay, so we're done with 11th and 12th plus 6 months of lockdown. Nothing is overdose now. Alright. So yes, okay, you are very, very, very near the number of my age. You are quite near there. It is somewhere around that. It's actually 35. Okay. So obviously next would be 3C over 2L. So you will, this is nothing but this is 2 times nu naught. Alright. Then next possible would be 3C over 2L, which would be 3 times nu naught. So these are the different modes of vibrations that you can have. So what will this be called? This will be called the third harmonic, third mode of vibration, and the second overtone. Alright. Okay. So this is how you define these terms. These terms should be known to you because they ask you about these terms very, very commonly. So in general, what I can say is, in general, let's write it down. In general, if nu is NC by 2L, then this is called the nth mode of vibration. Nth mode of vibration. Alright, this is called the nth harmonic. So how do you decide the harmonic? Whatever be the multiple of the fundamental frequency, that is called the harmonic. Alright, and this is called n minus 1th overtone. Alright, this is what names you will give this. Okay, so I hope everybody is clear. So all these are natural frequencies, by the way. All these are natural frequencies. Alright, like a pendulum has only one natural frequency, right? Which was root G by L, right? So a string which is bound at 2 ends has multiple possible natural frequencies. So all these are called natural frequencies of a string, and they appear in different modes of vibrations. So I hope everybody remembers this. If everybody remembers this, then let's try some problems regarding this. Okay. Two bodies M and M of equal mass are suspended from two separate massless strings. String constant. Okay. So okay, I had left one more for this. So but yeah, I wrote everything here only. Alright, so yes, I think I wanted to write this stuff on the next. That is why I left the second one open. Okay. So why don't you try a problem till then? Till the time you try this problem, I will take a look at your question. Okay. So this problem says that in terms of T, nu, and L, find the frequency of the fourth overtone and the third harmonic. Okay. So two bodies M and N equal masses are suspended from two separate massless springs or spring constants K1 and K2. If the two bodies oscillate vertically such that the maximum velocities are equal, the ratio of the amplitude of vibrations of M to N is. Okay, so this is very easy. This is very easy. Okay, what is this? This is super easy. So there are two SHMs. There are two SHMs. So one is happening like this. So you have M mass and K1, and another is again M mass and K2. And you have been told that they have the same maximum velocity. Okay, so let's see what is the omega for this. Omega 1 would be root of K1 over M. Similarly, omega 2 would be root of K2 over M. Now the maximum velocities, you should know what are maximum velocities. V1 max would be A1 omega 1, which will be equal to V2 max, which should be equal to A2 omega 2. So A1 over A2 would be nothing but omega 2 over omega 1, which would be root of K2 over K1. Alright, so there you have your answer. Okay, yes, that is correct. And that is correct. Absolutely. So here you know this would be fourth overtone means fifth harmonic. So that will be 5 C by 2L, and C obviously is 5 by 2L times root T over mu. Alright. So similarly this is the third harmonic. So this will be 3 by 2L times root T over mu. So alright, this was simple. Okay, so you got your answer also. Okay. Okay. So should we move forward? This is a pretty easy one. This was a pretty easy one just to make you remember what overtones and harmonics are. Okay. So the idea is to make you help you remember that. That is why I'm just giving you a practice problem for this. All right. So very simple again. So let's try this one now. Let's try this. So here you've been told a massless rod BD of length capital L is suspended by two identical massless strings A and B, AB and CD of equal lengths. Now a block of mass M is suspended from a point P such that BP equals X if the fundamental frequency of AB is twice the fundamental frequency of CD. Then what is the value of X? So solve this quickly. Solve this quickly. Hurry up and quickly solve this. Okay. Just write trying in the chat to let me know that you guys are trying. Okay. Okay. All right. So I hope others are trying as well. I hope everyone's trying. Okay. This is an easy one. Shouldn't be too difficult. L by 5. Okay. I really don't remember, but yeah, that might be correct. Yeah, yeah, that will be correct. That will be correct. All right. So pretty easy that one. All right. So the rod is massless. Yes, 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 yes. So both you people have figured it out. So rod is massless. So let's say here the tension is T1 and here the tension is T2. Now what will be the fundamental frequencies? So nu naught for AB would be uh, so 1 over 2L times root of T1 over mu. So how about their mu's? So they're identical massless strings. Okay, they shouldn't have said massless. They shouldn't have said massless. They cannot be massless. They should have small masses. These small mass, two identical strings having small mass. You guys would know that in massless string, the, the elasticity would be very high. So this would be V naught AB. Similarly, V naught CD obviously would be 1 over 2L root of T2 over mu again. So what would be the ratio? So of AB is to CD. So the ratio would be root T1 over T2. And this has been told to me as 1 is to 2. Right. So I was told that the fundamental frequency of AB is twice the subfundamental frequency of CD. So this is 2 over 1. So that just means that T1 equals 4T2. Alright. Now all I need to do is take the torques about this point. So if I take torques about this point, so let's call this point something. So if this was A, this was B, this was C, this was D, and the rod was massless, so this is T1, this is T2. So let's call this O. So let's take the torques about O acting on this rod, on the massless rod BD. So since the torque, since the rod is massless, also it is in equilibrium, so the net torque should be 0. Okay. So next what we do is taking torques uh, on rod BD, on rod BD about O. Let's see what we get. What we get is T1 into X would be equal to T2 into L minus X. Alright. Now it is very simple. You replace T1 by 4T2, so that would mean 4X equals L minus X, which obviously gives you X equals L by 5. So yes, absolutely correct, you guys. Alright, so this was a simple one, so I'm sure everybody followed this. Alright, so let's move and practice one more problem before we wrap it up for today. So here in this problem, you've been told a 3-meter long string sustains a 3-loop standing wave when attached to a heavy block as shown. The wave speed is 100 meters per second. Alright, so that would be the wave speed of individual waves constituting this. Alright, if the linear mass density of this string is 2.5 gram per meter, then A, find the frequency of the wave. Second, the lowest possible frequency of the standing wave in this string. And third, the mass of the block. Okay. So hurry up, let's just give me all these three answers and that is it. We will call it a day for today. Okay. Let us see some answers then. Start trying, guys. Start trying this fast. Okay, so Moisha is trying. Good. All right. Okay. Okay, 59 hertz. Okay, so the wave speed is there, and what has been asked? The frequency of the wave. Okay, so C by 2L. 3C by 2L. Oh, won't it be 50 hertz? Yeah, 50 hertz. Of course. 50 hertz is fine. So, yes, the first answer is correct. The lowest possible would be 50 by 3, of course. Of course, this is the third harmonic. So, the first harmonic would have one third the frequency. Very nice. What is the mass of the block? Find the mass of the block. Yeah, that would be very, very easy. That would be easy too. So, yes. So Vanchika has got all the answers correct, which is fine, which is nice. So I am sure then you guys have jogged your memories about standing waves and you are solving the problems correctly. So my job is done then. All right, great. 2.5 kg. So let's check these answers. So for the first part, obviously you know that C is 100, L is 3 meters. Since this has 3 loops, so you know for the first part that nu would be, this is the third harmonic. So the third harmonic frequency would be 3C by 2L. So that will be 3 into 100 over 2 into 3. So that is 50 hertz. So the first answer is absolutely correct. If this is 3C by 2L, which is 50 hertz, so nu naught, you know, nu 0. Alright. So nu 0 would be C over 2L, which is nu 2 by 3. So which is 50 by 3 hertz. Alright, so all that is correct. Alright. Next, I needed to find the weight of the block. So weight of the block would be equal to the tension, right? So I know this mg must be equal to the T. And I can find T from the fact that I know C. So for third part, I know C equals root of T over mu. So which would imply that T equals C square times mu. Alright, so okay, our mass of the block has been asked. So let's find the T first. So T is C square times mu. Mu was 2.5 gram per meter. So 2.5 gram per meter. Okay, so C square 100 square into 2.5 into 10 to the power of minus 3 Newton. So that will be my tension. So tension obviously is 25 Newton. And this would be equal to mg. So obviously m is 2.5 kg. So yes, so this is my third answer, this is my second answer, and this is my first answer. Alright. Yes, Moesha, I figured. Yes. So these parts were easy only. Yes. Most of you have gotten them right. So very well done. Congratulations. You seem to have revised your standing waves part. So this is where I would wrap it up for today. Tomorrow we will carry on the discussion from here. We will discuss the standing waves in an organ pipe, open organ pipe, closed organ pipe. Alright, and then we will talk about beats tomorrow. Alright, so make sure you're attending tomorrow's lecture also. Now before I leave you, let me remind you that if you haven't gotten your Unacademy subscriptions yet, you should be getting them. And this is how you do that. First, you install the app. Once you've done that, go to the plus section, select your goal as IIT JEE and click on Get Subscription. Now, please remember that IIT JEE is one of the most competitive exams, not only in India, in the world. So trust me, you guys, to crack this exam, you will need all the help that you can get. So Unacademy platform, trust me, would be a great help for you in this competitive environment. Alright, so make sure you are making use of that. And when you're getting your subscriptions, you will see the prices are very, very reasonable. Alright, and you have all sorts of options, payment options. So you have no cost EMI options. You can break this payment into any number of parts that you feel like. And you can use this code RD Live. If you use this code, then you will get a 10% off. Sir, did you see Friends or Big Bang Theory? Yes, yes, I've seen them both. Yes, they were. Friends, when I was in college, we used to watch all this a lot. Friends, Big Bang Theory, and even, okay, a lot of other series, I used to be a total series buff. Okay, so yes, I would watch a lot of movies, a lot of web series, and thankfully in IIT you had free internet even back then. Even back then, I in IIT you had like free high speed internet. Like most people have access to high speed internet now, but in IIT we always had access to very high speed internet absolutely for free. So yes, people would download all sorts of movies and web series and share it on the LAN, and we would just download things from the LAN. And I think any movie could be downloaded in like 5 minutes max. Sir, who's writer of University Physics? So Young and Friedman, there are two writers. I don't remember the full names, but there are two writers. First is Young, I don't know his first name, and another is Friedman. Okay, okay, maybe Hugh D. Young. Yes, maybe. All right. So, okay, so that is it. If you like today's video, then press the like button, share it with as many people as you can. As you know, for those of you who can't afford the subscription, okay, for those of you who can't afford the subscription, we are providing you quality content completely free, courtesy Unacademy on this JEE English channel. All right. So share it with as many people as possible and make sure more and more students benefit from this. All right. Okay, Anshuman. Okay, Anshuman. Yes, 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 yes. Vineet. It is a wonderful book, but it is this thick. It is this thick. That is the only issue. All right. Or it comes in two big volumes. All right. Don't forget to press the bell icon, and the PDF of all the slides used in today's lectures would be available for download in, let's say, 2 days. Okay. So for those of you who are following us on the JEE English channel, you can connect with us on the Telegram app using this link so that you're not missing out on any of the notifications of the lectures and sessions that are being organized here on this channel. All right. So that is it, guys. So I will take your leave now. Before I go, let me remind you, as I said earlier, this IIT JEE exam is one of the most competitive exams in the world. Okay, what? What? Oh, okay. Okay. So, okay. So before IIT, it was all studies, 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 and after IIT, it was no study at all. So it's very simple. It's very very simple. After IIT, it was all fun. After I went into IIT, so yeah. Trust me, I wouldn't want to share those stories after IIT. All right. Before IIT, it's the usual, yeah. Just a lot of hard work. But we had our share of fun also. In any case, maybe I will talk about that someday. All right. But I don't really want to do all that on YouTube. This is a public platform. Okay. Okay. Why? Why, Anshuman? Why do you feel that? Well, journey to IIT was very different from journey in IIT, was very different from journey after IIT. All right, so my journey has been very, very weird, very different phases of my life. Okay, okay. Yeah, I don't know. I don't know if I want to really talk about. There are things that I cannot really talk about, so I don't want to do that on a public platform like YouTube. There are so many people watching this, including my parents. I wouldn't want to say everything that I used to do here. It one obviously would not be a really good influence on you all, because trust me, I have done, or I have lived a quite a wild life. Okay, let's just say that. All right, and I wouldn't wanna influence you in a bad manner. Okay, so as far as YouTube is concerned, as far as public portals is concerned, All I did was study, study, study all the time and did not do anything else. Okay, that is what you should remember. Okay, how about my parents who could watch this? How about everybody I know? Yes, you have no idea, Vineet. Trust me, you have no idea. Okay. See, if you were in an offline classroom, maybe I could have told you some stories. All right. There I used to share some stories, but I don't think I can share many stories here online. Okay. Maybe I'll try to filter out some stories and maybe I'll share them one day. But I'll have to really apply huge filters. All right, I'll think about it, and maybe we can have such a session, such a fun session where we will just have a discussion. I'll tell you about my life in IIT before, after, everything. Okay. So anyhow, so before I leave, as I was saying, IIT JEE is a highly competitive exam. You will need all the help that you can get. So do this. Do this. Use this code RD Live and get your subscriptions fast because trust me, you do really need all the help that you can get. This subscription also gives you a 10% off, all right, along with unlocking all the wonderful features of Unacademy Plus for you. All right, so that is it. I will see you tomorrow now and we will carry forward our discussion tomorrow. All right, so bye bye, take care, and keep practicing.